So before us we have an equilibrium slash calculating a constant problem, and it states the data below refers to the following reaction. 2 nitrogen oxide as a gas plus bromine as a gas goes to 2 nitrisol bromide as a gas. So they give us a table here of initial concentrations and a concentration at equilibrium, and they want us to calculate the Kc. So I already know that I'm going to be using this kind of, I guess, formula or thing that goes on to every Kc. It's going to be the concentration of the products to the whatever stoichiometric coefficient it has over reactants to the power of whatever stoichiometric coefficient it has. So I have already written down here another table, but I'm using an ICE table, which is the initial, change, and equilibrium, so that way I can find out what the equilibrium constants are. So first I'm gonna go ahead and do that. So the change that I'm gonna be looking at is gonna be 2.5 minus, and right here I put minus because the concentration is gonna be lost. It's gonna lose something, and then because it has the coefficient of 2, it's gonna lose 2 times something. And then for bromine, we're going to have just 1, so it's going to 5 minus the 1x. And then, so whatever is going to be lost is going to be found by the nitrisol bromide. So we're going to have 1.0 plus, and then it has a coefficient right here of 2. So we're going to go ahead and put 2x. So it's given to us here already that the equilibrium of the nitrogen oxide is 2. So what I can do is I could just solve for x, so that way I can plug it into these two and find out the equilibrium concentration. So I'm going to put 2 is equal to 2.5 minus 2x. So we can subtract both sides, 2.5. So we can cancel these out. So we're going to get a negative 0.5 is equal to negative 2x. And we're going to divide this by negative 2, so we can isolate that x. And we're going to get 0.25 is equal to x. So I already know that this one's 2, so I'm going to plug it into here. So I have 5.0 minus x, which is our 0.25, is equal to 4.75. So I'm going to put that here, 4.75. And then for our nitrisol bromide, we have 1.0 plus 2 times x, which is, we know is 2.25. It's equal to 1.5. So we have 1.5 here. Alright, so going back to this kind of formula here, or we can say that Kc is equal to our products, so that is our nitrisol bromide. So nitrisol bromide, that are NOBr, but because there is a coefficient here of 2, we're gonna put a little square here over the concentration of our reactants. So we have the nitrogen oxide that has a coefficient of 2, so we're going to put it to the power of 2 times our bromine gas. And then, so we already know the concentrations at equilibrium, so we can plug in corresponding. So we can have our remember, you don't want to get confused going this way and plugging in like that. That's what I was about to do. So just remember that we already written it down, so this is actually 1.5 squared over 2.0 squared times 4.75. And we're going to take out our handy calculator. We're going to plug that in. So I like to use a lot of parentheses just so I know my calculator knows what I'm talking about. So we have our 1.5 squared, and this is divided by divided by our 2.0 squared times our 4.75, and that gives us 0.12. So we know that our KC is equal to 0.12.